Hi friends, welcome to the Unit 3, Day 2 notes. Now we're in Example 2. This is synthetic division. Synthetic division is a simulation of long division. It basically takes out all of the variable parts and uses the coefficients because it operates under an assumption that works with only linear types. So synthetic division works only with linear divisors. So in this case, this x cubed minus 4x squared plus x plus 6 by x minus 1, doing this with synthetic division, we can do it because this x minus 1 is a linear term. If it was not, we would not be able to do that. We already know the result. We actually did this problem already in long division, but I want to show you how it works so you can compare the two and see the similarities and the differences. So with x minus 1, using synthetic division, the way we set that up is we have essentially a box here that we're going to use as kind of a location for what would make our divisor 0. What would make the divisor 0? So this part right here, what would make that 0? Well, the number 1 would make that 0, so that's what we put here in this box. It's always what would make that 0 as we operate. The coefficients of each of these terms, so 1 for x cubed, negative 4 for x squared, 1 for x, and then 6 for our constant term. Draw the line, bring down the 1, and then I'm going to multiply through. 1 times 1 is 1. Negative 4 plus 1. So when we combine these, we do it by addition. Negative 4 plus 1 is negative 3. Negative 3 times 1 is negative 3. Combine these, we get negative 2. Negative 2 times 1 is negative 2. And then I usually draw a longer vertical line here and then 4. This 4 is a remainder. And then these are your coefficients of your terms for each of the parts of the remaining polynomial. So when we divide this by synthetic division, we obtain x squared minus 3x minus 2 with a remainder of 4 over x minus 1. And that is, as you note, our problem from earlier. Jumping to example 2b on the next page. So again, this is now a different problem. I'm dividing x cubed plus 3x squared minus 4x minus 12 by x plus 2 using synthetic division. Using synthetic division, remember I have a box here, and it's whatever would make my divisor 0. If I plug in a negative 2, that makes my divisor 0. Now my coefficients, so 1x cubed, 3x squared, negative 4x, and negative 12. Again, my coefficients. Bring down the 1. Take 1 times negative 2, negative 2. 3 minus 2 is 1. 1 times negative 2 is negative 2. Negative 4 plus negative 2 is negative 6. Negative 6 times negative 2, positive 12. Combine those together, you have a remainder of 0. This means that x plus 2 is a factor of this polynomial. We're left with then x squared plus x minus 6. You could actually factor this out even farther and end up with the whole factors of this particular polynomial. So I just want to point out, this is when we divided x cubed plus 3x squared minus 4x minus 12 by x plus 2. So we end up with this as our result. So I'm asking you to compute this quotient. Again, quotient, same as when we do fractions, using synthetic division. So the part that goes here is going to be what makes my divisor 0. So x minus 3, that would be 3. And then now my coefficients. A lot of students will miss this part. It's 2 for x cubed. There's no x squared term, so we need to use 0 as a placeholder. If you don't, you'll end up with the wrong answer. We need a linear term, so 3, and then our constant is 7. Bring down the 2. 2 times 3 is 6. Bring down the 6. 6 times 3 is 18. 3 plus 18 is 21. 21 times 3 is 63. Then I have a remainder of 70. That is okay. A lot of students will be nervous getting very high remainders. No, that's perfectly fine. So this, the answer, the result, the quotient to this division problem is 2x squared plus 6x plus 21 with a remainder of 70 over x minus 3. Whenever I ask you for the remainder, unless I notate it in a particular form where we're multiplying by the x minus 3, please note that we need to write the remainder as a fraction over the x minus 3 to show that this is our remainder. So we can only use synthetic division for linear types. We can't use it for any degrees that we're dividing that are higher powers. So the example that we're going to get into in number 3, note that we're going to have to use long division for it. We can't use synthetic division because it's an x squared minus 2. I had a student ask, Mr. Brumman, what if I turn it into dividing linear? What if I can factor it and make it linear terms? Often you have a situation like this where it's not easily factorable. Now, this one you could divide by x plus the square root of 2 and x minus the square root of 2. That doesn't sound like fun. I would not enjoy doing that problem. It would be a lot of extra work for what I feel like long division would give us an easier value or an answer. Join me in the next video as we go over dividing polynomials using long division for these higher degree powers and exponents.